Hello everyone. Let's start introduction to Docker. What is Docker? Docker is a containerization platform that allows developers to package applications and their dependencies into lightweight portable containers. Think of Docker as a way to create a box that contains everything your application needs to run: the code, runtime, system tools, libraries, and settings. Imagine you are moving to a new house. Instead of packing each item separately and hoping everything fits in your new place, Docker is like having a standardized shipping container that works everywhere. Your application runs the same way on your laptop, your colleague's computer, and production servers. Why use Docker? Benefits over traditional virtual machines. Traditional virtual machines versus Docker containers. Virtual machines or VMs. Each VM runs a complete operating system. Heavy resource usage, GB of RAM, and storage per VM. Slow startup times in minutes. Hardware virtualization through hypervisor. Docker containers shares the host operating system kernel, lightweight, MB of overhead, fast startup times, seconds, operating system level virtualization. Key benefits of Docker. Number one, consistency. It works on my machine becomes it works everywhere. Efficiency. Number two, efficiency uses fewer resources than VMs. Number three, scalability. Easy to scale applications up or down. Number four, isolation. Applications run independently without conflicts. 5. Portability. Run anywhere Docker is installed. Speed, fast deployment, and startup times. 7. Version control. Track changes to your application environment. Key Docker concepts. Number one, images. A Docker image is like a blueprint or template for creating containers. It is a read-only package that contains application code, runtime environment, libraries, dependencies, configuration files. Analogy: think of an image as a cookie cutter. It defines the shape, but it's not the actual cookie. Actually, you may think of it like a blueprint or a plan. From that plan, a house can be built. So, the plan is images and containers are the house. And if you know object-oriented programming, you may think of images like class and containers like objects. Number two, containers. A container is a running instance of an image. It's the actual environment where your application executes. Analogy: if an image is a cookie cutter, then a container is the actual cookie made from that cutter. Key points about the containers: lightweight and fast, isolated from other containers, can be started, stopped, moved, and deleted. Multiple containers can run from the same image. Dockerfile. A Dockerfile is a text file containing instructions to build a Docker image. It's like a recipe that tells Docker what base image to use, what files to copy, what commands to run, how to configure the environment. Example, Dockerfile structure from Ubuntu colon, this is the version of the Ubuntu, this is base image. Now, then copy app.py to /app/ copy files. Now run run pip install flask, install dependencies. Now cmd, the main command. This is within third brackets or square brackets because this is an array of string. This is Python within quotes, comma, this is /app/app.py within quotes. This is the default command. We shall discuss it more in next some future lessons. 4. Docker Hub. Docker Hub is a cloud-based registry where Docker images are stored and shared. It's like GitHub for Docker images. Features: public and private repositories, official images, Ubuntu, Python, Node.js, etc. Automated builds, version control for images. Installing Docker. Windows installation. Option 1. Docker desktop. This is recommended. I'll show you where to go. Here, go to here, search for Docker desktop. Yes, this one. Here you can find, making it at top, you can find it download for Mac Apple Silicon, download for Mac Intel chip, download for Windows AMD 64, download for Windows ARM 64, download for Linux, etc. Okay, so this is how we can install, mainly for Windows or Mac. I'm using Mac right now and I've installed it before. Slideshow. Windows check requirements. Windows 10 or 11 Home or Pro or Enterprise or Education. 64-bit processor with second level address translation SLAT. 4 GB system RAM, BIOS level hardware virtualization support. Number 2, download and install. Visit Docker Desktop for Windows. Run the installer. Follow the installation wizard. Restart your computer when prompted. Enable WSL2 if prompted, otherwise it's not required. Open PowerShell as administrator. Run WSL -- install, then restart your computer. Number 4, verify installation. Open command prompt or PowerShell. Run docker -- version. Option 2, Docker engine for advanced users. For Windows Server, or if you prefer command line only installation, use Docker engine with WSL2. macOS installation, I have installed in this way. Docker Desktop for Mac. Check requirements. macOS 10.15 or newer. Apple chip M1, M2 or Intel chip. This is the older Intel chip. 4 GB RAM minimum. Download and install. Visit Docker Desktop for Mac. Download the appropriate version, Apple Silicon or Intel. Drag Docker to Applications folder. Launch Docker from Application. Verify installation. Open terminal. Run Docker -- version or Docker -v. Let's try this out. This is our terminal, Docker -v. Okay, Docker version 28.1.1 build something. Okay. Next. Slideshow. Linux installation. Ubuntu or Debian. Update package index, sudo apt-get update. Install required packages, sudo apt-get install certificates called GNUPG, then lsb-release. Add Docker's official GPG key. Those commands are there. Then set up repository, this one. Then install Docker engine, sudo apt-get update, sudo apt-get install Docker C, Docker CCL, etc., etc. And add user to Docker group, optional, to run without sudo. Sudo usermod -a capital G Docker, the $user, new grp Docker. CentOS or RHEL, that is Red Hat Enterprise Server, Fedora, etc. Install required packages, this one, sudo yum install this one, sudo yum this one, then install Docker engine, this one, then sudo systemctl start Docker, sudo systemctl enable Docker, add user to Docker group, optional, sudo usermod -a g Docker $user. Okay. Your first Docker command, hello world. Now that Docker is installed, let's run your first container. Step 1, open your terminal. For Windows, command prompt, PowerShell or Windows terminal. For macOS, terminal application. For Linux, terminal emulator. Step 2, run the hello world container. Docker run hello world. What happens when you run this command? Docker checks locally, looks for the hello world image on your computer, downloads the image, if not found locally, pulls it from Docker Hub, creates a container, instantiates the image into a running container, executes the program, runs the default command in the container, shows output, displays a welcome message. Container exits. The container stops after completing its task. Okay, this is the expected output. Let's try that on my system. Docker run hello world. Unable to find image locally, then it's pulling from this. Then finally, it shows that this is the output. We shall discuss this, show you output and discuss it. It's like that. Unable to find image, hello world, latest locally, latest pulling from library hello world. This complete this hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client contacted Docker daemon. The Docker daemon put the hello world image from the Docker Hub. The Docker daemon created a new container from the image, which runs the executable that produces the output you are currently reading. The Docker daemon streamed that your output to the Docker client, which sent it to your terminal. To try something more ambitious, you can run an Ubuntu container with Docker run-it, Ubuntu bash, share images, automate workflows, and more with free Docker IT from here. For more examples and ideas, visit this. Understanding the output. Unable to find image locally. Docker didn't find the image on your computer. Pulling from library /hello world. downloaded from Docker Hub, hello from Docker, the actual program output. Explanation, Docker explains what just happened. Verify Docker installation, run these additional commands to confirm everything is working. Check Docker version, Docker -- version or Docker -v. Check Docker system information, Docker info. Check Docker PS, running container should be empty. List all containers, including stopped ones, Docker PS-A. List downloaded images, Docker images. So let's try this one by one. Go here. I pressed Ctrl L to clear that window. Check Docker version, go Docker -v. Docker info, Docker info. It's showing the Docker info. Now Docker PS, Docker PS, it shows Docker PS. It is empty right now because no images, no container is running. Docker PS-A. You see that this container ID is this, image hello world, command is /hello 3 minutes ago, exited 3 minutes ago, this names is this, and finally Docker images. It shows you this one, hello world, and created when and its size. Now let's go to our Docker desktop app. Go here and you have seen Docker, this one, Lucid Storm. It is shown here, this one. And name, container ID, images, etc. And here is the images, this one, installed here, volumes, builds, etc. Okay. Go here. That's all for now. Thank you.